So section 3.3 is going to be very similar to section 3.2. In fact, there's going to be no new bits of information. If we start off right away with a theorem, and this is going to be theorem 3.5, and it's the corresponding angle converse. It's a very, you're going to feel like you've seen this before. And if you watched my 3.2 video, you definitely have seen this before. It's going to say the following: if corresponding angles are congruent, then the lines are parallel. So last time we started with the lines being parallel, ended up with having corresponding angles being congruent. This time we're starting with corresponding angles being congruent. The lines have to be parallel. That just kind of makes sense. So if we go ahead and look at this, the examples, the steps you're doing in the examples are not going to change. Your thought process is going to be the same. The only difference is the wording is going to be a little bit different. We're going to ask, I want to find the value of x to make these two lines parallel. And so if we take 3x plus 5 here and 65 degrees down here, well, those are corresponding angles. And if those corresponding angles equal one another, then this line M must be parallel to that line N. So all we need to do is take 3x plus 5, set that equal to 65 degrees, and solve for x. Well, we'll subtract 5 on both sides to get 3x is equal to 60. Divide by 3 on both sides to get x is equal to 20. And that's it. That's everything else you're doing today is going to be exactly the same. All right, if I go ahead and draw another little demonstration right here, and we say that this is line M and that this is line N, and we cut this by a transversal, and we would say that this top one is 75 degrees. This bottom here is 105 degrees. Is line M parallel to N? Well, of course it's going to be parallel because 75 plus 105 is equal to 180 degrees. And although we haven't done well, actually, we can prove it using our corresponding angle theorem because this angle has to equal 105 degrees. And now 105 corresponds to 105, so they have to be parallel. Really, we're not doing anything different today, so that's great. It's a little bit of a mind break. Same sort of questions. If we look at theorem 3.6, which is going to be our alternate interior angle converse, it's going to say the same exact thing as what we just said. It's going to state that if alternate interior angles are congruent, then the lines are parallel. So if alternate interior angles are congruent, then the lines are parallel. Likewise, theorem 3.7 is going to state the alternate exterior angle converse, and it's going to say that if the alternate exterior angles are parallel, if the alternate exterior angles are congruent, then the lines are going to be parallel. So all we need to do is replace this word interior right here with the word exterior. And then finally, we're going to have theorem 3.8, which is going to be the consecutive interior angle converse. And this one says that if the consecutive interior angles are supplements, so they add to 180 degrees, then the lines are parallel. So all the examples you'll be doing today are going to be very similar to the ones you just did last section. Basically, find a value of x to make the lines parallel. Last time it said the lines are parallel, find x. This time it says find x to make the lines parallel. Same exact sort of thing. The final theorem I want to do with you today, very short section I know, is going to be theorem 3.9. And that is going to be the transitive property for parallel lines. And so if we draw 3 lines, P, and we're going to go ahead and just, oops, let me go ahead and redraw that. We're just going to copy this guy. Oh, that's not what I wanted. We're going to copy them. We're going to paste right there. And we're going to paste this third one over there. You get it? We have 3 lines. And what this is going to say is if this is line P, Q, and then R way over there, let's say that P is parallel to Q. And Q, I'm going to draw it this way, is parallel to R. Well, if P is parallel to Q and Q is parallel to R, then you can conclude that P must be parallel to R. It's just a transitive property. And so if we go ahead and draw now 3 parallel lines, and we cut them all with a transversal like that, and I state that this angle is 115 degrees, and I want you to find the value of x down here. Well, that's going to be a straightforward process. You know, that's going to be 115 degrees. That's going to be 115 degrees. Now we're on a straight line, so we're going to take 180 minus 115 degrees, and we're going to find out that that angle is equal to, quick math time, pull out the calculator, 65 degrees. So that's all I have for you today. The section is very short. It's just a converse of literally the entire last chapter, or that last section we just did. So if you need more help, please go back and watch the section 3.2 video. Thank you all, and I'll see you in the next one.